Hi and hello. In today's lesson, we're going to continue our work with operations on polynomials. We're going to explore how to multiply two polynomials. We want to figure out how do we multiply polynomials and what kind of expression do we get as a result. So first, I'd like to point out that we can extend our area model for multiplication into a volume model for multiplication of polynomials. If I've got three polynomials I want together, we're effectively finding the volume of a rectangular prism. The volume of a rectangular prism is length times width times height. So the volume of this rectangular prism is x plus 3 times x plus 2 times x. It's a fairly direct calculation, but suppose instead I want to use the second image. So in the second image, we're dividing the rectangular prism into four smaller prisms. Where kind of like in our area model, we would separate x plus 3 into x and 3, or x plus 2 into x and 2. So I divided it up into four smaller rectangular prisms, which I can then add together to get the total volume. This should give me the volume in an expanded standard form polynomial rather than in the factored form like we have for a. The dimension of each prism here is a monomial, so I can find the volume of each fairly simply. Let's look at C. If I want to find the volume of V1, if we look on our picture, each side length is x, so the volume of V1 is x cubed. And now for D, I want to find the volume of rectangular prism V2. So its bottom side length is x, its left side length is now 2, but its height is still x. So this is an x by 2 rectangular prism, or 2x squared. Continuing down the line, let's find the volume of V3. V3 is a 3 by x rectangular prism. So its volume is 3x squared. And finally, I want to find the volume of V4. Its dimensions are x by 3 by 2. Which gives it a volume of 6x. So now if I want to find the total volume, I can add all of them together. I can find the sum. So total volume is equal to V1 plus V2 plus V3 plus V4. So x cubed plus 2x squared plus 3x squared plus 6x. Now I can combine a couple of like terms, so x cubed plus 5x squared plus 6x. That is our total volume. We would get the same thing if we distributed A. So I'd like you to reflect, if all three were binomials, how many regions would it be split into? Now let's come and do some more multiplication. So multiplying polynomials involves multiplying several monomials together. So you need to be able to understand how this works. So to multiply two monomials, you multiply the coefficients, and you add the exponents on any variables they have in common. So here for 5x times 6x cubed, 5 times 6 is 30. And then we'd have 1x from the 5x and 3 more from the 6, so 30x to the fourth. Important to note that 4 is only on the x, it is not on the 30. So now let's take a look at our next example over to the right. It's got a few more variables, but it's still the same idea. We multiply our coefficients, so negative 2 times 5 is negative 10. And then we add the exponents for any variables they share. So x squared, y to the 2 plus 4, and z to the 1 plus 1, which we can simplify down to negative 10 times x squared times y to the 6th times z squared. All right, coming down to the next one. Now we have two binomials that we're multiplying together. These are binomials because they each have two terms. And this is something we've done in the past. To multiply two binomials together, we use the distributive property. So I'm going to take that 2, multiply it by 1, and then again by the x. And then I'll take that 3x, and I'll multiply it by the 1, and then I'll multiply it by the x. So it gives me 2 plus 2x plus 3x plus 3x squared. And again, we'll just combine our like terms. 2x plus 3x is really just 5x. All right, so now let's go through 3 examples of multiplying two polynomials together. So each one of these has a trinomial that has 3 terms. And I'm going to show you 3 different ways that we can multiply. We'll distribute, we'll multiply vertically, and then I'll use the area model, which we've already seen before. So to distribute, what I'll do is I'll just take the x and multiply it by each term. So x times 1 plus x times negative 4x plus x times 2x squared. And now I'm going to take the 2 and distribute it. So we'll have 2 times 1. There's a typo, it gets fixed. Then we'll have 2 times negative 4x. And then we'll have 2 times 2x squared. Important to note that I am putting plus in between all of these, though some will change to negatives later. So we have x minus 4x squared plus 2x cubed plus 2 times 1, minus 8x plus 4x squared. And now that I've done all of my monomials multiplied together, I'm going to go ahead and combine like terms and rewrite it into standard form. So starting with my x cubed, I have 2x cubed. Now, interestingly enough, that negative 4x squared cancels with that 4x squared, so I don't have any x squareds left over. But x minus 8x is minus 7x. And then plus 2 doesn't have any like terms to combine with. So that's how we can multiply two polynomials together by distributing, using the distributive property. All right, so now I'm going to multiply these two polynomials out vertically, kind of like if we were to multiply two numbers together. I will show the work in that same fashion, so I'll write it out in standard form, negative 7x squared plus x plus 2. And I'm going to multiply that by 3x minus 4. Now, just like we would multiply two numbers together, I'm going to take that 4, multiply it by each term, put it a 0, and then multiply 3x by each term. So negative 4 times 2 is negative 8. Negative 4 times x is negative 4x. And negative 4 times negative 7x squared is 28x squared. So now I'll drop a 0. And I'll distribute the 3x. So 3x times 2 is 6x. 3x times x is 3x squared. And 3x times negative 7x squared is negative 21x cubed. All right, and then just like if we were multiplying two numbers together, we are going to add down to get our result, negative 8, negative 2x, 31x squared, and negative 21x cubed. All right, and finally, I do want to show us also using the area model. Really, it's the same as what we've been doing to multiply two binomials together. I know several of you use this method. I just need to make sure I add an extra row or an extra column for my extra term. So I'll start by doing what I've usually done. I'll split up my 3 and my 2x, draw the line in between it, and then I'll make 3 columns, one for each term of the other polynomial. So 4, negative 7x, and then 5x squared. So now I just find the product for each cell. 3 times 4 is 12, 4 times 2x is 8x, 3 times negative 7 is negative 21x, and I'll just keep going. All right, so now that we've got that multiplied out, we just need to find the sum. We'll combine our like terms. So 15x squared and minus 14x squared, just make a plus x squared. Negative 21x and 8x, make a minus 13x, and then plus 12. So this is how we multiply two polynomials together in 3 different ways. Now let's try an application. Let's model with polynomials. So here we have this whole problem. Mr. Silva manages a manufacturing plant. From 1990 through 2005, we can model how many units it produces using this function, where x is just our time since 1990, and we can measure the cost using the second function given. Total manufacturing cost is the number multiplied by the cost per unit. If we multiply the number of units by the cost per unit, that gives us the total cost for the operation. So we'll just take those two functions given in the problem, multiply them together. So 0.02x squared plus 0.2x plus 3, and negative 0.002x squared minus 0.1x plus 2. So here we have it. This function represents the total cost in years since 1990. Thank you so much.